name's Derek Peterson. I'm with the Cornell Municipal Department, and I'm here to tell you about a unique sealing system called the Cornell Cycloseal. First, I want to kind of go over the basic components of the Cornell Cycloseal. As you can see, we have a drawing of cut out of one of our pumps. This area here is what we call the Cycloseal sealing system. The first component of the Cyclosealing system is special designed impeller back vanes. The function of the impeller back vanes is to throw solid particles out of the sealing chamber as the solids come in. We also utilize a niche backplate design. The niche backplate area is designed so that the fluid can come down into the seal chamber and pull the seal faces. We have our rotating faces here and our stationary seal faces here. We also have what we call our deflector vanes. Our deflector vanes are designed to help keep solid particles from going down into the seal chamber. Let's talk a little bit more about the deflector vanes first. Deflector vanes are designed so that as solid particles flow across these vanes, they trap the solid particles on the outer edge of the seal chamber. They act in an eddy effect. And when I say an eddy effect, I mean that as the solid particles flow across them, the little air pockets here are all trapped behind those deflector vanes. As a result of that, the solid particles are not allowed to go down into the center of the pump where the seals are located. Those air pockets of solid particles are then evacuated by the specially designed impeller back vanes. One thing to note, Cycloseal utilizes standard off-the-shelf John Crane type 1 and type 2 single seal. So it's a sealing system, it's not a special seal. So if you need to go to your local John Crane dealer to get a replacement seal, there doesn't seem to be any problem doing that. We offer the Cornell Cycloseal with carbon versus ceramic for standard service and tungsten carbide versus silicon carbide seal faces for abrasive service. When talking about abrasive service, we did some testing here in the Cornell lab. We ran silicon sand through our test facility for 300 hours to see the effects on soft faces. And after that 300 hours, we found that the seal faces were still good. In fact, the seals were still completely usable, as if they were brand new. What we have here, this is the original backplate that we utilized in the testing of our high abrasive applications. As you can see, if you look closely at the impeller, you can see on the outer edge where the deflector vanes are located, all the primer has been torn off when operating for those 300 hours. But as you get closer to where the seal will be located in the backplate down in this area, you notice that all of that primer is still intact, that the primer has not been affected. This helps strengthen our point that the solid particles do not make it down into the seal chamber. The solid particles stay on the outer edge of the system, not allowing the seal to be cooled by the clear poppage. This portion of my presentation here, we're talking about doing a live demonstration of how the Cycloseal works. And what we're going to do here is we're going to introduce air directly into the backplate. And in the backplate area, you'll see it fill up with air, and we're going to start up the pump and allow you to see the evacuation of that air out of the system. One thing to note, the Cornell Cycloseal design is designed to evacuate air out of the system automatically. And this is what we're going to demonstrate here. A Cornell Cycloseal requires no venting or flushing. As you notice, this pump is in a vertical configuration, and as many people are concerned about, you'll note that the backplate design here would allow an air pocket to be up toward the top. What we want to demonstrate here is that through the splashing effect and the evacuation of that air out of the seal chamber very quickly, the seal faces never have a chance to run dry or to get hot in any way. And what we are going to do here is first we're going to add air to our system. We're going to start up the pump, and we're going to look at how long it takes for that air to get out. and then we are going to add air while the pump is running. And then at the last point that we will do, we're going to crank down the speed of the pump to around 700 to 600 RPM to see how well the Cycloseal system works on a VFD application. What we have here is a 6 NHTB in the vertical position, and what you're looking at is a window that we have put in the back plate so you can see the seal in operation. As I zoom in closer to it, you'll be able to see the compression spring of the pump, of the seal. We're now going to start up the pump, and we're going to introduce air into the back plate right now for startup. As you can see, I've just put compressed air into the back plate, so on startup there is quite a bit of air in there. And what we're going to demonstrate here is how well the Cornell Cycloseal evacuates air on startup. We're going to start up at about 1200 RPM, and from there we're going to ramp it down later to 600 RPM and demonstrate the same concept. As you can see, what you're looking at right now at the bottom is the compression spring of the mechanical seal. The seal faces will be located at the top of the dish back plate. As the pump gets going, you can see less and less air in there. It becomes clearer and clearer. And as you can see now, you can see clearly through the piece of glass to where the compression spring is. That's because all the air in the back plate has been evacuated. We're now going to again add air into the back plate so you can see how well it does it again. The turbulence is the air going into the back plate area. Almost immediately you can see that air being evacuated out. We're now back to a state of no air in our back plate area. We're now going to ramp down the pump to around 600 RPM to show you that it does operate very well on a variable frequency drive. We're now operating about 600 RPMs, which is about a 2-to-1 speed range ratio for this pump. Again, we add air into the back plate area. And again, you can slowly see the air being evacuated out of the back plate area. You can now see the top of the compression spring, and now you can tell that all the air has been evacuated out of the back plate area. Let's go ahead and time it this time to see how long it takes to get that air out. We're at about 12 seconds to evacuate all the air out. And the one thing to note, even though there is air in the backplate system, the cyclone action of the back vane shoots from the backside of the impeller, shoots water up into the seal chamber constantly to keep those seal faces lubricated. In closing, the Cornell Cycloseal system is an excellent choice to seal a centrifugal pump. It works much better than what your traditional double mechanical seal, since it does not require venting or flushing. You have ease of maintenance because it requires no filters or